Hey everybody, Lars here. Thought I'd take some time tonight and go over the second part of the Unit 3 slides, the part on file input and output, but we usually just call it file I/O, so you'll see it listed as file I/O. File I/O is pretty important because when you get to the stage where you're actually writing programs to do work and you're actually, given some data in order to analyze or use, you're never going to be handed a program with a small list in it, or somebody's going to say, create a list of the first 200 numbers. We do that to learn and we do that to practice. But in real life, what somebody's going to say to you is, here, I have some data analyzed. Here's a file with the data in it. A lot of introduction to computer science courses or computer programming don't mention file I/O. And I remember when I was a student all those years ago thinking that was a little odd because it was pretty important. And I thought, having it be part of a course on computer programming should be a basic thing that's always talked about. But for whatever reason, back in the day, they taught you a whole bunch of languages. They would teach you C and Pascal and COBOL and Fortran and blah, blah, blah. A lot of times, file input and output wasn't even mentioned. So it was one of those things you had to teach yourself on your own when you got out there in the big, bad, real world. But we're not going to do that. We're going to look at file I/O really quickly. Not too quickly because it's an important topic and I do want you to understand it. Let me fire up Vinyl. And let's grab a new file. I like it. Okay. My comments. And author Mars. Good enough. Okay, so what is a file? A file is basically a computer or digital version of a document or a piece of paper or a group of information. I mean, we know files when we look at directory listings in Windows or Mac or whatever you're using as, distinct collections of data or programs to run or different things like that. So what we want to do is use these files as data. The thing about a file is when we run our programs and we create our list from 1 to 200 and we, grab lists of names and blah, blah, blah. When the program ends, all that data goes away because it's kept in RAM. A lot of times we're going to want to examine data and then save the results of our work somewhere. We don't want to just print it or do something like that. So files basically act as durable digital storage. So if you want to keep some data and read from that data all the time, you can use a program to access a file, or as we're going to see at the end of this little demo, you can make changes to your data or do whatever the job is you have to do and then save your results to a file so that you can either, give it as a deliverable to whoever needs it, or you can even use it as input to the next part of a process. A lot of times you'll write programs which will take data and get it ready to be used in another program and then save it to an output program, and then that output program will become input to the next stage in the process. But the first thing we're going to do is, and did I make one already? Well, I can use E22. Actually, what I did, E22 is that file with 5,000 different names in it, and it's a little unwieldy for demonstration purposes. So what I did was I created a smaller one with names in it. So why don't we just write a simple piece of code that reads that file. Now, in Python, basically dealing with files, at least reading them in, is a three-step operation. The first thing you want to do is open the file and associate it with a variable name. So I'll create a variable called infile, and I'll make it equal to, I think I called it small e22.txt. The name of the file. You want that in quotes. Okay, so I just use a variable with a string in it, so I can just make that change in one place and it would change it everywhere in the program that I need to use it. Now, very simple variable name, forgive me. I'm just going to call it F, and I'm going to say open infile, comma, and in quotes R. Now what I'm doing is I'm telling Python I want to open small e22.txt because that's the string that's in that variable. And the R tells Python I'm opening it for reading. I want you to prepare to read this document when I tell you to read this document. So now we have the file open and the variable f is associated with that file. So what's the next step? The next step is reading. We want to read in from that file. And the way Python handles files harkens back to a programming language called C, which in actuality is Python's grandfather. A lot of Python is written in C, and a lot of things that we do in Python, if you know C, it kind of makes sense. C could open files in different ways. One way was called random access, where you could go to different spots in the file, go to the middle and start reading, go to the end and start reading, and do things like that. Python doesn't open files that way. Basically, the way Python deals with a regular data file is to open it in what's called sequential mode. You're going to start at the beginning, and then you're going to go from item to item all the way down until you get to the end of the list. And this is basically looked at as what we would call an input stream. If you just think of the data you're reading in as a long string or a stream of data, I'm guessing somewhere down the line you're going to hear that term, input streams and output streams. If you have any experience with the programming language C++, you've definitely heard that term before. So, and this will come into play a little bit later when we talk about pickling. I'm going to bring this up again, which is why I'm letting you know now. But when we open that file and we associate it with that variable f, we're basically saying, okay, sit there on the first spot and wait for me to tell you what to do. And we are basically right now going to do the simplest thing we can do. We're just going to say data equal the variable dot, and then I'm going to run a method that it has called read. And I'm going to read that entire file and put it into the string data. So when you read from a file, what you're doing is you're producing a large string. Depending on your memory on your computer, strings in Python can be huge. So they use strings, and then we use string manipulation methods in order to clean our data up and get it ready to use. But let's not get ahead of ourselves. Although, to be honest, basically I'm just going to do this. I'm going to print the data. Now, before I do that, I'm going to talk about the last step in the process, and that last step is to close the file and tell Python, okay, we're not going to use this anymore. We're done. So let's save this. Code. I'll call this eread.py. Good enough. And when I run it, it gives me that file. Now I think that file, well, I can't really break it down by names right now. Well, we will in a second. So that's the file that I read in. It is a considerably smaller version than the big E22, the one that I grabbed off of Euler. I shrunk it down as 200 and something names. We'll look at that in a second. So that's basically how we set up Python. We associate the file name with a variable, and then we take that variable and we read from it and fill the data string. Then we have our data. In that variable data, we now have the contents of the file, and we can do what we want with it. And when we're done, we just say close. Now, we're dealing with data science here, so there's going to be a lot of situations where you're given a file and you're going to want to process it and you're going to want to do something with it. Right now, all I have is one huge string with all my data in it. I could find out what the length of it is. I can do some other things, but what I really want to do is get to the nitty-gritty and separate all those names out so I can do things and examine those names. So basically what we want to do is make sure we are up with our string methods, because what we're going to do is we're going to take this string, and the first thing I'm going to do is I'm going to say data equals to data.replace, and I am going to get rid of those double quotes. And the way I want to do that is with a single quote, I say replace the double quotes, comma, with what I want to replace it with, and that's nothing. Not a space, nothing. Two single quotes in a row right there. So now if I print the data, let's see what we get. I'll get two in a row. Okay, I get the version up top where I just read the file in, and then I get this version down here, and as you can see, all of the double quotes have been removed because I ran the replace method. I said go to every place there's a double quote and just put nothing there. Just get rid of it. So one last thing that we can do, and this happens quite a lot, is we'll make a list with the data. So I can say data equal to data dot split, and if you remember the split method, it will take everything and break it up by a delimiter that you give it. Delimiter is just something that separates. It's used quite a bit in computer programming. So what do I want to do? There's a comma there, so I want to tell it use the comma as the delimiter, and what this will do is make a list out of data. It will take that string and basically reuse the variable name, and the return from data.split is a list, as you will see in a second, because when I do print data and run it again, you'll see now it's a list. See the bracket, and then in single quotes separated by a comma, it goes down, and we can now do whatever we want. You can see there were 235 items in the list, so there's 235 different names. Okay. What else can we do? Now that we have a list, for I in data, boom, print I. We could do it line by line and print them all. It's not as big as the other one, so it went rather quickly. Okay, so now that we've read our data in and we've cleaned it up and created a list, now we can do things with it. We've created a situation where we've modified our data, so now we can use all of our tools. We can use our functions like len, or we can iterate through the data, which is usually the format that you want, so you can begin to create a block or create a list of commands that you're going to do for every single item in order to start discovering things about it. Okay, so that's the basics of reading in data and using it. Now, there's a couple other things I want to show you about files. So I am going to, I guess I'll leave, do I want to leave that? Yeah, I'll leave that. And we'll go here. Now, there is a part of the slides. Do I have the slides up? Look at that. Where I discuss there it is, an easy Pythonic method of reading files. And this allows us to read the file line by line, because a lot of times we'll be given files and each line will be a separate data item, be it a number or be it a name or something like that. Sometimes you don't get a big long sequential list. You want to read things line by line. And with as, Python gives us a quick way to do that. So why don't we go code that up right away. In file, I can say with open in file, comma, read. You do the same thing. The only neat thing about it, with open in file as f, and I'll call it f, and then I will say for line in f, and then line by line I will get the file. What can I do with those names? You know what I think I'm going to do? I'm going to do something different. Watch. I'm going to go here to Notepad, and I am going to create a file. Good enough. I will go to File. I will say File, Save, and I will call it mynums.text. Good enough. Now, Notepad is very clean as far as an editor is concerned. No special characters, no craziness. It's not like Microsoft Word. When I use Notepad, I'm creating a clean sequential file. I could get some new lines in there, some tabs, but not much more than that. So mynums.text. So now I have a file called mynums.text, and it contains those 7 numbers line by line. Let's say I'm going to read that. mynums.text. All right, good to go. So then with this structure, I could do something like this. Let's add them all up. I could say accum equals 0, and then I could say accum equals accum plus, I want the number, because I'll read it in as a string, of the line. And then after that, I can say print sum is, comma, accum. And let's see what this gives us. The sum is 315. I'm hoping that's right. Let's take a look. One thing we can do to make sure at least our program is working is we will change one number, save, rerun the program, and as you can see, it's one less. Hey, pie. So it's one less, so I'm pretty sure I'm good to go here. Okay? So that is how we can read a file line by line. Every time through this 4-line loop. See, this creates a scenario where I'm just using the file, that with as. Then 4 lines in, I create a block that's going to work within that file. So 4 line in F, I then loop through the lines. Then when I get to the end, I drop out to a regular line here. That ends the with as. So when the block underneath the with as ends, then the with as closes up that file. So InFile has now been closed up. If you noticed, I went through the open process, but I didn't go through the close process, and I'm not really using a read. That's what makes the with as special. If you know you're going line by line and reading things that way, you can use this as a quick shortcut in Python to read files line by line. One other thing that we do want to discuss now is another part of the equation, which is writing to files. I can read files, I can print them, I can change my data around and then use it with my loops and do things like that. But what if I get a set of results and then I want to write those results to a new file? So that when the program is ending and everything is done, I don't just print it to the screen for a printout. I actually save my data in a real file. That's very useful and is something that we are going to do right now. So let's say I say OF file. Well, that's a crummy name, but we'll go with it. And I will call that my outnums.txt. You can give it any name you want because you're creating it now. I want to open this one, so I'm going to say outf for out file, open all file, comma. Now I don't want an R. I want to use a W in this instance because I'm opening this file for writing. So when we go to use that variable, you're going to see I'm writing things to it. I'm not reading from it. So we've got to tell Python that's what we intend to do. So now I have an open file called outnums.txt. I'm using the variable outf with it that I can use to write results to. So, okay, you know what? With what we have currently right here, we'll keep this intact. But what we'll do at the end of it is we will, let's do this. outf.write. So I'm telling it to write to my output file. Now what should I write to it? I will write string. Now, you know what I want to do? Let's do this. For line in F, let me say num equals int line, so that I make it an integer there. Then with my accumulator I will add num. But now I have the number that I read from my nums in integer format. So I will write the string version of num plus 1 plus a \n, and I will explain that in a moment. Outfile write to the string. Okay, so when I run this particular piece of code, I've set up an InFile. Now I've set up an output file. I open that output file so it's ready to be written to. Accumulator 0. With, open the in file as F. I come down into the block where I'm using that file. For line in F, so in this loop, it's going to see F as a sequence, and each line will be an item. So I take the line, I make an integer out of it, I make it equal to the variable num. Then I add it to the accumulator. Then I write to a new file, but I write that number +1. And then I write a new line, and I'll explain that in a minute. Write, like we explained the file thing before, does sequential writing operation. So if we just wrote without that new line, we would just get a line of numbers. With this, I guarantee by writing the new line that I will get a list of 7 numbers like I had before. And then we're just going to print the sum like we did last time. Hopefully it'll still be 314. All right, let's see what we get. Okay, it says the sum is 314. And okay, that looks good, that looks good. Let's go look for my new file called outnums.txt. Here we go, outnums. Great, it's sitting there. Awesome. Let's double click it and read it. Uh-oh. It's empty. There's nothing there. Why do you think that is? I think I know, because it happens a lot, and people have to remember. We forgot one last step. When you open a file and then you read, or if you opened it for writing, then you write to it, especially with output files, it's very important not to forget that last step. And the last step that I did not do was to close it. When you close it, you're telling Python, I'm done with it. It's now ready. It's a regular file. So now that I've closed that output file, I think I run it again, we're going to be in business. Let me pop out here and refresh. Now I have outnums, and now I look at it, and I have numbers, and that's my output file. Do I have my input file still up? Yes, I do. Hot damn tonight. And as you can see, it's been increased by 1 in every instance. So what we did with our file is we read these numbers in line by line. I added it to the accumulator because the result still showed us it was 314. And then I added 1 to it and wrote it to the new output file. So the program grabbed it, added it to the accumulator, added 1, wrote it, added 1, wrote it, added 1, wrote it, and down the line in that loop, we created a new number. Now, you obviously are going to do much more interesting things with your data than just add 1 to it and write it to a new file. But this is the basics of what you're going to do. You read in data, you analyze it, you use your algorithms on it, you perform the tasks you have to perform to get the answer you want, and then you can write it to a new file. So in this case, I've written to the file outnums and created a list where every item is 1 greater than the numbers in the mynums. Okay? So this file, eread.py, I will put up on Sakai, so you have 0 worries about that. So that's the basics of file I/O. You open a file and associate it with a variable. Then you use methods on that variable in order to read from the file, take your data, manipulate it so that it's usable, create a list so you can iterate over it. A lot of times you will get what are called CSV files or comma separated values. Well, we can handle them very well because we can then use the split and remove all the quotes from anything that has quotes around it, and then everything will just be separated by a comma. We use our split with the comma as the delimiter, and we read all our data into a list where we can then start doing things with it. There's also the special way here using the with as block to quickly read a file line by line. Python has quite a few neat little ways of doing things that we don't really do in other programming languages. At some point I may show you list comprehensions. That's another neat thing that we can do in Python. But that is for another time. And then the fourth thing that we have to be concerned with is output files. You can then create an output file, any name you want, associate it with a variable, and you can write to it. So you can do things with your data and then write to the file, just like you'd be writing to the screen. Because technically the screen is just another output stream. And you learn that when you program in C too. You learn about standard input and output, and where we read our data from, our different input sources, and where we can send our data, which is our different output sources. So one output source is send it to the screen. That's what print does. And another one is what we're doing here. Grab a file and run the write method, and it will write to this file. And then when we remember to close, because we are clever, then you're going to have a good file with your data in it. Now, when I kill all of these programs, tomorrow morning when I get up, that file's still going to be there. Outnums is still going to be there with my results in it. I can then take it, print it out, read it into a new program. It's durable. It's durable storage. So it's just another level of things we can do now. We don't have to worry about keeping everything in the program and printing things out and doing it and keeping our data like within the code. We don't have to hard code our data anymore. We can read things from files, and you're going to see if you do any programming in a professional sense, it's all file input and output, reading from configuration files to make programs work a certain way, reading data from files. That's the name of the game. So I thought it was very important for you to see something like this before we ended our little 6-7 week crash course in imperative Python. Because after we get through with this unit, you'll find that we're going to be less learning about Python and more using Python. So we're going to use it to do computer science stuff. We're going to use it to do data science things. We're going to add a little bit more when we learn about object orientation, but you'll notice a slight curve in the road. As we move forward, we're going to start using it to do neat things instead of just learning how it works. One last thing I'm going to do very quickly, because I'm not going to write any code about it, but I did want to mention pickling. This is going to be more easily understood when we get to Unit 5. Unit 5 is about what's called object orientation, and there you're going to learn about classes, which are just these blueprints about how to make objects. And you'll notice an object is nothing but a construct that includes a whole bunch of different data that you want to relate together, and the functions, although in this context we call them methods, that you can run on that data. Now, back in the day, most file writing operations were like the early files that I told you about. They were sequential. You had to just write them out in a straight stream. So people started using more advanced data structures, like we use lists, and when you see objects, you're going to see objects or more complex data objects. The problem was you couldn't just take an object and write it to a file. You had to take that object and examine it and then code it in a way where it was nothing but a sequential set of characters, because that was the format you needed in order to save to a file. That's where we get the term serialization from. Think about the term serial. You just want things to go in a line. So what pickling is really what's called serialization. It's taking a complex data structure and putting it in a straight sequential line of characters so that it can be saved to a file. And a lot of programming languages, C++, now Python, create ways for us to do this easily so that I can take my list, as in the case of our slides, or I can later, I'll show you in Unit 5, take an object or take other special complex data items and create that sequential line, save it to a file, and then when I read a pickle file back in via load to reload it, I think dump is the command in order to save it, then all of a sudden I'll have that sequential line read back in, but the pickle will go the extra step and recreate the complex object that it originally was. So I'll get back my list, I'll get back my object. A long time ago, 70s, this used to be called marshalling. And for whatever reason, you hear marshalling a lot. I mentioned this in the slides too. You hear marshalling a lot when people talk about data warehousing and data mining and data science things. So it's funny, everything comes full circle. Marshalling is actually a better way of dealing with complex objects when we talk about object orientation, because it not only saves your data, it saves the things you can do to your data as well. So it's really a complete solution. But I didn't want to give you the pickle stuff and then not mention it in this particular video. But we're not going to do any code with it. I wanted you to see it because we might do some things with it in Unit 5, and I find it interesting, and it was a very good segue into importing libraries and using third-party code. So I just imported pickle, and I pickled a couple lists. But that's basically all you have to know about pickling. Pickling is not that complicated. It's basically file I/O like we just did for the last 15 or whatever minutes. But it will take a complex object, make it a straight line, then save it to a file, and then when it reads it back in, it'll take that straight line of data, and through different algorithms and codes that it uses, it will reconstruct that complex object. So that's all there is to say about pickles. It's not that big a deal. I'm not going to throw any pickling stuff on the test. Don't worry about thinking, oh my God, I have to know all the methods for the pickle module. No, you don't. You don't have to know a thing about the pickling module. Trust me on that one. All right? So I wanted you to see that as a last thing. So where's my code? So that's the basics of file I/O. I just want you to know about the basic 3 steps. You open your file and associate with a variable. Then using that variable, you read your data into a regular variable. Then you can manipulate it, do what you want, create a list out of it, do what us programmers do. And then at the end, you close the file and say, I'm done with this. Now, as you saw with the R and the W, you can open files for reading or you can open files for writing. As usual, there are myriads of different options with this too. You can open files for binary writing. You can open files for read and write. You can do a lot of other things. This is the basics, and I want you to get used to seeing this and get used to the process before you worry about all that other stuff. Because right now we're saving the files with sequential characters. You could save bytes if you want. You can do a great many things when you save your data. But we're not worried about that right now. We're worried about simple file I/O. Sequential file I/O with just regular characters. Okay, so that is the review for the file section. Know this, I'm sure one of the programming assignments is going to include reading some data from a file, but it won't be super complex. So don't be concerned if you've watched this video and you've read the slides, and you'll have a decent understanding of it, and it won't be difficult at all. Okay. Tonight I sent out your grades. If you didn't get an email with your Unit 2 grades, shoot me an email and let me know, because everybody should have had them. Everybody did great. Super happy. As you probably know, I did the video for cow pie last night. So go watch that. If you haven't watched that yet, it explains assignment 1 from Unit 2. And tomorrow, the next day, Eric and I are going to be sitting down and really hashing out the basics of your big final project, a rubric, what we expect, what we want to see in the proposal, what we want to see for maybe a little presentation, and then different, stages of the code and different things along those lines. So we're going to bang that out. I really want you to engage with the materials, do some of the small programs that are in the slides and things like that. So I haven't been giving you the assignments right away at the start of the unit. I really want you to do things with these other things first, and then I'll give you the assignments to do later. So I'm probably not going to release the assignments until maybe Wednesday or Thursday, but we'll see. All right? So that's the second video. The third video, the one on modularity, where we import all the libraries and we start using those things, probably will show up on your doorstep later this week, maybe Thursday or Friday. I really would like to get it to you before the weekend, so you have the weekend to work with a lot of these materials, and then you'll have all the review videos, you'll have the complete package, you'll have your assignments, and life will be good. All right? Then I'm getting out of here. I'm actually going to get some sleep tonight. So you have a good night, and I'll see you later. Bye-bye.